Hello all, welcome back to yet another problem of the weekly contest 324, and it is the third problem, and it is tagged as hard. And yeah, we need some many observations for this problem to be solved. So the problem is add edges to make degrees of all nodes even. So there is an underrated graph consisting of n nodes numbered from 1 to n. You are given the integer n and 2D array edges where edges of I equal to ai and bi indicates that there is an edge between ai and bi. The graph can be disconnected. You can add at most two additional edges. We can add only two additional edges to this graph so that there are no repeated edges and no self loops. So we can add only two edges, only at most two edges. We cannot add more than three or two. So return true if it is possible to make the degrees of each node in the graph even, otherwise return false. So the degree of node is the number of edges connected to it. So for this graph, we can add only two edges, at most two edges to make it even. As you can see, the number of edges for one is 2, it is even. So the number of edges for 2, it is 4, it is even. The number of edges for 5, it is 1, which is odd. The number of edges for 3 is 2, which is even. And number of edges for 4 which is 3, and it is odd. So we can add one edge between 4 and 5 so that the number of edges for 4 and 5 it becomes even. Having four edges for 4 and two edges for 5 respectively. So we can add only one. We are adding only one edge, so we return true. In the example 2, we are adding, as you can see, that 1, 2, 3, 4 all contains only one edge, one in degree edge, and it is all odd. So we can add an edge between 1 and 3 and 2 and 4 to make it even. Also now all the nodes will be having an even number of edges. So we can just return a true since we are adding only two edges. But in the example 3, we are having the number of edges for 1 is 3 and the number of edges for 2, 3 and 4 is 1. And we cannot add only two edges to make it even, because if we want to make this if we want to if we can consider we are having let me depict here. For example 3, 1 has 3 edges and 2 has for 1 edge and 3 has 1 edge and 4 has 1 edge. So consider we are adding an edge between 2 and 3. If we are adding an edge between 2 and 3, this becomes 2 and this becomes 2. So now we can have even number of edges between 2 and 3. But you can see the number of edge for 1 and 4 is still odd, and you cannot add another edge between 1 and 4 because already there is an edge between 1 and 4 and you cannot add any self loop edge to 1 and 4. So since we cannot add one edge between 1 and 4, you can never make it even number of edges for every nodes, adding two edges alone, at most two edges alone. So we return false. That's why the example 3 is having a false. So how we are going to solve this problem? So as you can see, one observation that we can note here is we can add only at most two edges. To add at most two edges, you can have only at most 4 nodes to have odd number of edges. If it is having more than 4 nodes which is having odd number of edges, we can never we can never make all the nodes having an even number, adding at most 2 edge. Because if we consider, if we are having 6 nodes with odd edge and we want to add at least 3 edge between them to make it even, right? So we cannot add at most 2 edge. So we can return false if there is more than 4 odd values. So that is the first observation first observation in this problem. So what is the first observation? If the number of nodes having an odd number of edges is more than 4, then we can directly return false. And the next observation that we can handle is, if the number of nodes having an odd number of edge is equal to 1 or is equal to 3, we can never add an edge, we can never make it all even by adding at most 2 edge, because there is only one node with having an odd number of edges. Adding an one edge between that node and with other node which is having an even number of edges will make it other node to be odd. So we can not we cannot return true in that case as well. So this is the second observation. Hope I am making clear. I will say once again, you consider we are having a 3 nodes which is having an odd number of edges. We can never add 2 edges or at most 2 edges, so that it making it all even. So we can return false. So what is the second observation? If my number of nodes which is having an odd number of edges is 1 or is equals to 3, or if it is greater than 4, we can return false, directly return false. These are the two observations. So what is the other observation? If the number of nodes is 2 and if it is equal, if the number of nodes is 2 and if the its number of what does that mean is, if the number of nodes is 2, if it is having an odd number of edges, then we can try to add these both these both nodes to the other single node which is having even number of edges. What does that mean is, consider we are having 3 nodes. 1, 2 and 3. Let us say this is going to be a disconnected component. One is not connected with anything. Consider we are connecting 2 and 3. So 2 is having an odd edge and 3 is having an odd edge. So these are the 2 nodes that we want to make it even. So this is a case where we cannot add a self loop. We cannot add an edge between 2 and 3 to make it even. So what we can do is, we can add an edge between 1 to 2, so that this becomes 1 and this becomes 2. And again we can add an edge between 1 and 3, so that the number of edge between 1 is 2 and the number of edge between 3 is 2. So hope I'm making it clear. You can actually understand what I'm trying to say. If it is already connected, if the odd edge is already connected, we can never connect them again. So if we are not able to connect them again and there is only 2 nodes left out, we can connect with the some other node which is having even number of edges, so that making it plus 2 and making it plus 1 which is 2, and this also becomes 2, so that we can make all the nodes to be having even number of edges. So this example is quite simpler to understand why I am saying this, so that we can handle this case as well. So we are handling this case as well to solve this problem. So these are the 3 observations. If you didn't understand the observations, you get go back and see once again, so that you will clearly understand. Now I will walk you through the code to get an understanding. Maybe it is thinking it can be seem to be quite long, but it is not that long if we handle every cases. So I am having a vector of int nodes which is going to count the number of edges between the nodes. This is going to act as a map, and I'm going to have a map which is connected. I'm going to make a graph. This is a graph, but I'm having a set inside it. For each node I'm going to have a set which are all connected to it. I'm going to insert into my set, so that I can find whether that is already present in that set or not. If there is an edge between them, why I should not add an edge between them if it is already present. So that's why I have kept a set here. So what I'm doing is, first I'm going through all the edges. So we are I'm going iterating through all the edges, and I'm mapping it in my nodes of edge of 0 plus plus, and this is nothing but I'm counting the number of edges, and I'm also inserting it into my map, so that I can know which are the edges are that are connected. So I'm having a vector int odd. This is nothing but I'm going to insert the nodes which are having odd number of edges. So I'm also having a count here. Now I'm traversing for all the nodes from 1 to n, and I'm checking whether if the nodes of I is an odd, then I'm incrementing my counter, and I'm also pushing that node into my odd vector. If my count is going to be greater than 4, then I am returning directly false, because I can never have more than 4, because I should add at most only 2 edges. So I will be returning false. After coming out of this loop, I am checking whether my count is equals to 1 or my count is equals to 3, because it should not contain like this. If it is there, then I can never add at most 2 edges to make it all the nodes even. So I am also handling another case, so I am returning false. And next what I'm going to do is I'm having some variables x, y and added edges. Let us see what is this happening. So what does this to for loop does is I'm going to add an edge. I'm going to add an edge. Greedily adding an edge between the odd number of edges is the most easiest way that we can do, instead of adding it to an edge which is having an even number of edges. What I mean here is, if one is having two edges and 2 is having a one edge between 1, and 3 is having an one edge between 1, this is a graph where 1 is connected with 2 and 1 is connected with 3, so that 1 is having 2 edge and 2 is having 1 edge and 3 is having 1 edge. So if I'm having like this, then 2 and 3 will be present in this odd vector, and the easiest way that I can do is I can add an edge between this 2 and 3 if it is not connected. If it is 2 and 3 is already connected, I want to tend to connect with the nodes which are having even number of edges. But the greedy approach is that we want to add an edge between the odd number of edges itself, so that I can increment this by 1 and I can increment this by 1, making it even. So that's why I have run two for loop to the odd vector where I'm finding all the pairs and I'm trying to add the edges. Because it is going to have only at most 4 or at most 2, I can try to add an edge between them if it is possible to add it. So I'm having a for loop 0 to count, and j starts from I plus 1 and j less than count and j plus plus. These two for loops explores all the possible pairs in between them. And I'm taking x as odd of I and y as odd of j, that is the nodes, that is the node. So this nodes of x is nothing but the number of nodes, number of edges and number of edges for y. If both the number of edges are odd, then what I want to do is I want to check whether I can add an edge between them. How when I can add an edge between them? If it is not present, if there is an edge not present between x and y, then I can add an edge between them. That is what this check is doing. If my MP of x is not having an edge between y, and if my MP of y is not having an edge between x, then I can try to add an edge between them, x and y. So I will increment nodes of x plus plus and nodes of y plus plus, and since I have added one edge, I will be counting added edges plus plus. I will be incrementing the added edges. So I want to insert the nodes between them in the map also. So MP of x dot insert of y and MP of y dot insert of x. So this for loop will try to add an edge between them. And after doing these conditions, I am checking whether the added edges is less than or equals to 2. If my added edges is less than or equal to 2, and this check of nodes is nothing but this is a simple check. I am trying to go through all the nodes in my nodes vector and checking whether there is a odd number of edges present. If there is no odd number of edges present in my nodes vector, I am returning a true. Else, if there is any odd number of edges present, then I will be returning false. So this is a quick check, because we want to have all the nodes having even number of edges. So that is why I am having a check here. If my added edges is less than or equals to 2, or my check of nodes is returning me true, then I can just directly return true. Else, now what I want to do is I want to handle the other case, the case that I previously discussed. If the two nodes is already mapped with them and it is having an odd number of edges, I want to map it with the node which is having an even number of edges. So that is the check, that is the case I am handling here. That is a easy check. How I can handle this? I want to first find the total number of total number of nodes that are odd. So again I am running a for loop for odd vector. As you can see, that is the at most the size of the odd vector is only 4. So I will be counting the num plus plus. If my num is going to be 2, that is there is only 2 nodes that are present. If that is the case, then I want to note which are the nodes that are which are the 2 nodes. So that is why I'm having x as -1 and y as -1, and I'm running a for loop in the odd vector. And if it is going to be odd, what I'm going to do is, if it is an odd and I'm checking if my x is equals to -1, then my x is going to be e, else my y is going to be e. Hope you understand. This simple check can get the 2 nodes which are having odd number of edges. So we have got the x and y. Now what we can do is, we can run a for loop from I equals to 1 to n, and while I'm going, what we can do here is, what we are going to do is nothing but we want to have an add an edge between the two odd number of edges with the one node which is having even number of edges. So I am checking if my MP of I is not having x, is not having an edge between x, and if my I is not having an edge between y, then that is the only node where I can add both the edge x and y. So that already I is having an even number of edges. So adding plus 2 will make that I again even number of edges, and I am adding 1 to my x, so that odd plus 1 will become even number of edges. And y is also, I will for y node also I will be adding 1 with even, so that it will become even number of edges. Sorry, 1 plus odd, 1 plus odd, and again there will be 1 plus odd. This both will become even number of edges, and as you can see that I, x and y is all becoming even number of edges. That is the case we are handling here, right? So nodes of I will be added by 2, and nodes of x and nodes of y will be adding only one edge to them. And what I have done here is, I have added 2 edges, which is I to x and I to y. So I want to increment my added edges count. So added edges count is incremented by 2. So hope you understand this case. And after this condition, again we are having another check. If my added edges is less than or equals to 2, and my check of nodes, this check of nodes is going to check that all the nodes are having even number of edges or not. If it is so, then I am returning a true, else I am returning a false. So this is a quick observation that we can do with handling other cases and solving this problem. As you can see, we are handling many cases. That is why we are having the difficulty tag to be hard. And hope this is the problem. Let us submit the code as well. Yeah, it gets accepted. Hope you like the solution, and let me know. I can improve my explanation if you need it. So that is it for this video. Let us see in the next weekly contest problem. Until then, bye.